So we've previously defined the lookup function on our own very simple lookup tables that were just lists of pairs. And we have observed that there is one problem, namely that we have no other choice at the moment than to let the function crash in the case that we cannot find a particular key, right? And that is unsatisfactory. Now, the solution to this is to change the result type of the function. Right, the problem at the moment is that the result type of the function is val, and we don't know anything about val, and in particular, it forces us to produce a value of some unknown type that we do not have. What if we put instead a result type here that is some variation of val, but that tells us that we can either produce a successful result, a result of a successful lookup that actually carries a value of this type value, or it can be a failed lookup, in which case we are not able to produce anything. So basically to capture the notion of potential failure in the result. Okay? So how can we do this? Well, we can create a new data type, LookupResult, which has two constructors. One that says lookup failed, right? And one that says lookup successful. Only that, of course, if we do this, then the data type is more or less equivalent to bool, and we don't actually get the value at all, right? We only get the notion like, did we find the key or did we not find it? So in the successful case, we do want to get the value, and because the value is still supposed to be of possibly different types, we have to make the value a parameter of our lookup result data type. And then we should better be deriving show for it so that we can actually show values of this data type. And then we can change our lookup function to not produce a value, but a lookup result of value. And now there are two options that we have, right? We have to produce one of these two constructors, but the new thing, or the fundamental difference, is that now we have the option to say lookup failed, and thereby to produce a value of lookup result of val, right? Because if we perhaps let me undo this last change and just reload here once, so that I have the data type available in GHCi, because lookup failed with this definition, right, is a constructor of this new type that I have defined. It's a constructor and it produces a value of lookup result val. So I can use this constructor to denote that we are in this situation here and produce a type correct result. Okay. So if I say lookup result here, I now get a type error down here. We'll get to that, but first let's focus on the thing that it's still not incorrect to call error, right? Because error can be something, can produce something of any type. Crashing is always possible, but it's undesirable in itself. So the good thing is that now here we can actually write lookup failed, right? And in the other problem is now here we are just returning val in the successful case. That is no longer possible now either, right? We are now not producing something of type val. We are producing something of type lookup result val. And that means that even if we have a successful result, we have to now wrap it in this lookup successful constructor. Right, and that takes a val into a lookup result val, and that's exactly what we have to apply here. So we have to say explicitly now whether our lookup has failed or our lookup was successful. But the good thing is that now we are not crashing, right? So now if I'm calling my lookup function on with 2, on the table, I forgot to pass the table, right? Example, I think it was just called. And this is one of these situations again, right, where a partial application of lookup2 is of a function type, right? It's a partially applied function. We don't have a show instance for functions. That's why I'm getting this error. So it's still a type correct application, but it returns a function type, so the result cannot be printed. But if I actually pass the second argument as well, I do get that the lookup was successful and the result is billable. And if I pass another value that is actually contained in my table, I get a successful result as well. And if I pass in something that is not there, I do get that the lookup failed, right? So this is actually good. And in fact, we could even do a call to map just as a practice of other things that we've seen before. So let's just try to take the keys from 1 up to 10, let's say, and look up all these keys in our example table. So how do we do this? Well, we map the function that takes the key out of the list, right, and then looks up the key in our example table. We map that over the list of numbers from 1 to 10. And then we see that for 1, the lookup is successful. For 2, the lookup is successful. For 3, the lookup is successful. For 4, it fails. For 5, it fails. For 6, and for all the others, actually, it fails because the next valid key in the table is actually 11. Right? Okay. Of course, this also changes how we have to continue working with the result of lookup. Now we don't get a value out. We don't get, in our case, we don't get a string out. We get a lookup result of string out of our call to lookup. And that means that if we call this function, we have to be prepared for the failure. We have to decide how we want to deal with it, right? In the situation that we're calling the function, we have to be prepared that we get back lookup failure. We cannot just assume we get a string back. And there are multiple ways to deal with that, right? So we could say, well, then we are using a default value. But in the call situation, we probably know whether there is a reasonable default value we could assume or whether there isn't, right? Or we could propagate the error to the end user in some way. Or we could say perhaps we have a different table in which there are more items stored, and we could look in this other table perhaps instead, right? But the point is that we now get a structured data type which we can use in other functions, and we can decide. It gives us control. There are all sorts of options we now have, and we are forced to deal with them in a disciplined way, rather than just having something crash and not being able to properly deal with it. Okay? Now, this notion of something failing is so common that rather than having a specific data type for this that we call LookupResult as here, there is actually a, let's say, generic data type in the Haskell Prelude that we can use for this purpose. And this data type is called maybe. And if we just look with info at the definition of maybe, we'll see that the structure of the definition of maybe is exactly the same. And this time there is no magic syntax either. It's just different names as the structure of the data type that we've defined for LookupResult, right? So the parameter here is called a rather than val, but that doesn't matter. The type LookupResult is called maybe, right? That symbolizes that rather than promising that we're returning something of type A definitely, we're actually possibly returning something of type A, but possibly we're failing, right? And the constructor that we use to denote failure, we called it lookup failed for this specific situation, but in the general data type, it's called nothing. And the constructor for denoting success, we called lookup successful for our particular situation, but in the general situation, it's called just. Okay. So what we can do is we can rewrite our lookup function to use this maybe data type. Then we don't have to define our own data type. So let's keep the definition of lookup result. Let's just change the definition of lookup. So we're no longer using our data type that we define. So I changed the result type to maybe. Then, of course, the application of lookup failed and the application of lookup successful here become type incorrect. We have to fix them. But rather than lookup failed, we're now using nothing. And rather than a lookup successful, we're now using just. There is a trade-off between using our own specific data type for this scenario and using a generic predefined one, right? So the advantage of using maybe is that I already hinted at the fact that we now have lots of options on how to deal with such a result that can also be failure. And for maybe, there are libraries. There are lots of functions already predefined that handle maybe types in various different ways, and we have lots of useful functions available. Whereas if we define lookup result as a new specific data type for this purpose, we don't have any functions that work on lookup result. We have to define them ourselves. At the same time, lookup result carries more meaning, right? Like if we actually use constructors such as lookup failed or lookup successful, that they convey more information to the end user. Also, we could easily extend lookup result to be even more suitable for this particular scenario. For example, in the case that the lookup failed, we may actually still want to have some information, like which key did we actually look for. So we could actually extend the lookup result type to have information about the key and embed that into the lookup failed constructor, so that we basically, like when things fail, we get an error message, so to speak, that contains the key that was not that was not found. Right? So that is a trade-off, and there's no general rule whether it's better to define your own domain-specific things or whether it's better to use predefined, more or less generic data types that are available. You have to make a case-by-case analysis as to what's more important. Right? The only thing to keep in mind is that in principle, it is very easy to define your own data types, and you should not shy away from this. Anyway, so in the Prelude, as I said, the lookup function is even in the Prelude, and I think I can perhaps, by using a qualified name, even make that clear. So even though we've hidden the Prelude function, I can access it in GHCi here by explicitly prefixing it with prelude dot. We see that it has essentially the same type as our lookup function. In particular, it returns a maybe result type, only that the type variables are called differently, but rather than key, it's just using A here, and rather than val, it's just using B here. So it's a completely equivalent definition. Okay. So this works, right? So this is a much better definition of lookup than the one that was crashing. And we should now explore a little bit further how we can deal with maybe values, right? With results of type maybe. And I'll do that in the next video to explain these notions that we can perhaps look up a key in a different table if it wasn't found in the first, or that we can use a default value if a lookup failed. I'll go through these two examples next.